This is the smallest unit of meaning that makes up a referential frame, I think. It has three elements, one of which links the mind to the body. Actually, the mind-body problem isn't that difficult to solve once you take a pragmatic, once you look at how the brain works from a pragmatic perspective, because then your consciousness is fundamentally something that's grounded in action. And you can understand the transition between consciousness and action as a sequence of analysis that are increasingly action-oriented. I'll talk to you about that a little bit later, but the basic framework is something like this, and you're always looking at the world through this framework, and the framework has, as one pole, where you are and what you're doing, where you are now. So that's point A. You're always trying to get from point A to point B because you're a linear creature and you're embodied, so you're moving. And so fundamentally what you're looking at the world through is a sequence of maps, and maps tell you how to get to where you want to go. And so the map specifies where you are because obviously you can't get anywhere if you don't know where you are, and many people of course are confused about where they are so they don't get anywhere. And you also have to know where you're going, and that's point A and point B, and every time you look at the world you're looking through a framework that has those two valued points implicit in your cognitive structure. And generally what you think is where you're going is better than where you are, because otherwise why would you go there? Now some people do choose to go to places that are worse than where they are, but they're a special case. You probably live with some of them. Now when you're going from point A to point B, fundamentally you have to move. Now movement is not abstract. Movement is what you do with your body. And so once your abstract representation transforms itself into action, you're no longer in the realm of abstraction. So in order to get from one place to another, you have to know where you are, and you have to know where you're going, and then you have to walk, fly, run, roll. You have to perform some sort of embodied action to get there. And of course, you have conscious control over your voluntary muscular system, but underneath that, you don't really have anything at all, right? You can move your arm. You have no idea what muscles you're moving. So your conscious representation of your body grounds out basically at voluntary movement of the larger muscle systems. So now you might ask, well, what does specify where you're going? And the answer to that, in large part, is biology, but biology in a complex manner. And this is where higher order morality starts to become a concern. You share with other animals, all the way down the phylogenetic chain, various forms of implicit motivation. And you know, you can kind of lump those. It's arbitrary. I lump them into self-maintenance motivations and self-propagation motivations. You can cut that in different ways. Like I said, it's more conceptual than based on, say, you know, anatomy. But it'll do. Self-maintenance, well, you don't want to get too hot, you don't want to get too cold. Your hypothalamus deals with that, a very old part of the brain. It's way more important than your cortex. You can take the whole cortex off a female cat, and as long as you keep it in a cage and it has its hypothalamus, it can pretty much behave like a cat, except that it's hyper-exploratory, which is the last thing you'd expect from an animal with no brain. You can't be too hot, you can't be too cold, you got to regulate your water intake, you have to eat, you have to deal with the consequences of eating. You have to be with other people. There's a play circuit, a specialized play circuit. There's a specialized erotic circuit. There's a specialized circuit for exploration, which is about half of what the hypothalamus does, by the way. And those systems, they've often been conceptualized as drives, but they're not really that. They're more like isolated, one-eyed personalities. They're like cyclops. They want one thing. Now, they're not stupid, but they're not very amenable to argument. So when you're hungry, and you know, another motivational system might object to that, and that happens frequently, which is partly why people are often confused, and also why you need a cortex, because you know, you need a cortex to allow the competing motivational systems to array themselves properly and harmoniously across time so that they all get their due, instead of fighting like 2-year-olds in a room, because 2-year-olds are basically hypothalamic, you know, and so they're lots of fun, but they're not organized and they're not social at all. So what happens with the motivational systems very deep in your brain is they specify the value of where you are, so that one of the values might be, I'm thirsty. And then they tune your perception so that things that are associated with the quenching of thirst are much more likely to be picked up by your perceptual system. And they bias your perceptual processing and your valuation towards improvement of that motivational lack. And so you can't really think of them as drives because they're way more complicated than that. They specify where you are, so there's an element of self-consciousness that's associated with that. I'm thirsty. And they specify a target, usually using fantasy. You know, you get thirsty, you think, well, what would I like to drink? And you get a little fantasy about maybe a glass of juice or a bit of water or something like that. And then your nervous system is tuned, and then you walk into the kitchen and you ignore everything that's irrelevant to the search for liquid, and you focus in on everything that's relevant to the search for liquid, and that means you're so blind you cannot believe it. I mean, there's been many experiments now that have shown that you can do things like, I'm sure some of you have seen this, you can introduce a gorilla into a basketball game, and 60 or 70% of the people watching, as long as they're paying attention to the ball, they won't see the gorilla. And it's not like a little tiny gorilla that's somewhere off in the corner. It's like main center, 6 feet high, beating its chest. And even when you know that, if something else changes in the background, you won't see that either. So as far as you guys know, the carpet could be changing colors 15, 20 times a minute. You wouldn't even notice it, unless you had some weird obsession with carpets. So